front of me, I have two different types of safety relief valves that you'll commonly see on blower packages. This is a spring-loaded relief valve, and this is a weighted relief valve. So when do you choose one over the other? So if it's on a static system, and let's say it's just an air service, you're not moving any sort of nasty gases or anything like that. Let's say it's pneumatic conveying or aeration, I strongly recommend going with a weighted relief valve. The design's been around for over 100 years. It's a robust design. There's only one moving part. So the only way that valve really fails is if it seizes shut. And if it does seize shut, all you have to do is take a pipe wrench to the top, breaker free, take the top off, clean it up with some crocus paper, and it's back in service. Now, a spring-loaded relief valve, when it fails, usually the spring is what has actually failed within the valve. That valve is going to have to be replaced. There's no real good way for you to service it, because once you take this bonnet off, you've now changed the set pressure, and you're going to want to confirm what that set pressure is before you put it back on the system. There is a way to rebuild spring-loaded relief valves, but it's not advisable unless you really know what you're doing. So it's best to just have that set at the factory. We're going to go ahead and get into weighted relief valves, what they look like, what the components are, and how they work. All right, here is a fully disassembled 2-inch weighted relief valve. So the three main components you're going to have is you're going to have a piston, a top, and the weights. So I'm just going to go ahead and put it together. This piston here will screw into your system. This is a 2-inch NPT connection. Will thread right into your system. You have the top, and you can see it's a pretty tight fit. And then we stack the weights on top, and that is what's going to control the set pressure. Now this top without any weights is set at 1.5 psi. Each weight is a half psi. So this valve will now relieve at 2.5 psi. So it's a really simple design. You really don't have to worry about much failing. The only way this is really going to fail is if this top here rusts to the piston and the valve seizes. If that happens, all you have to do is take a pipe wrench to it, break it free, take the top off, and then clean up the bore of the top and clean off the surface on the piston. Put some lubricant on it. We typically just put VG220 blower oil on it to lubricate it, and that valve's back in service. Now I've gone over the three major components of the weighted relief valve, so we'll just go through each one individually, materials of construction and the coatings that are on them. So the weight itself is going to be A36 carbon steel, and then that's going to be zinc plated, and the valve is made out of 1018 carbon steel, and you can see this black coating on here is actually an E100 blackout Cerakote finish. All of the steel that you see in front of you is domestically sourced here in the United States. It is zinc plated in the United States, and the Cerakote finish is also done here in the US. So everything you see here is domestic. Now let's talk about maintenance for a second. So on these valves, every 3 months, we recommend that you go around to your weighted relief valves and just turn the top and make sure it turns. If it doesn't turn, it means that valve is seized for some reason. More than likely, if it's seized, it's because it's rusted shut. That's highly unlikely due to the Cerakote finish. That being said, if you don't have one of our weighted relief valves, and let's say it's a cast iron weighted relief valve, if that lubricating film of oil between the piston and the bore has flashed off, these two mating surfaces here on the piston and on the bore of the top, if that's cast iron and cast iron, what'll happen is it'll rust shut and it can seize and lock up the valve, which inevitably could fail your blower package if there's an event that causes that system to be overpressured. Your relief valve is not going to pop. So in terms of maintenance, if you are unable to do maintenance, or you think it's highly unlikely you're going to do any maintenance on it, whether it's you don't have the manpower or you don't feel you have the skill set, and again, it's pretty simple to do maintenance on these, we always have a 316 stainless steel option. It's significantly more expensive. That being said, it's pretty much a maintenance-free valve. We do recommend you still do your safety check on it every 3 months, and every year just put a thin film of oil on the piston and the bore. That being said, if you never service it, it's stainless steel on stainless steel. As long as there's no debris or anything like that between those two mating surfaces, this valve is going to continue to actuate and function. So if you don't think you're going to be able to do any maintenance, or you think it's highly unlikely you're going to do any maintenance, I'd strongly recommend you go with the 3/16 stainless steel valve version. Again, it is quite a bit more expensive, but it's a lot of peace of mind too. You really don't have to worry about that valve ever seizing shot. All right, so I'm back here at our test department. This valve is set to relieve at 4 psi. Before I go to test it, I'm going to do a quick functions check by twisting the top, just make sure it turns. This valve turns, so I know it's properly functioning. So I'm going to go ahead and put on my PBE, and then I'm going to turn on our test stand, and this valve is going to relieve at 4 psi. You won't really be able to hear it in the video, but what's going to happen is it's going to start to, the terminology is simmer or crack, and that's when you're going to see a little bit of lift out of the valve, and it's going to start relieving pressure. And then as that pressure continues to build, this top is going to continue to climb and relieve that excess pressure. So we'll go ahead and get started. Alright, so there you have it. That is a 2-inch weighted relief valve. We just did a quick functions check on it. We also ran it in our system, verified that everything worked the way it's supposed to. It cracked at 4 psi, and as the pressure built, I think the total pressure we got up to was 4.6 psi. The valve was in full lift, relieving all the excess pressure and flow from the blower package itself. That's our test stand. This is just a gate valve. I shut off and restricted all of the flow on the valve, so it was all venting through the weighted relief valve just like it's supposed to, protecting the blower package, saving your equipment, saving you a lot of money. It's worth investing. It's really worth investing in a good weighted relief valve that's not going to fail you. I'm going to go over how to select a relief valve. In this specific scenario, we're going to go over a 409 ram and a 412. Let's say I don't have much information about the system. I don't know what the system's flow is, and I just know what the set pressure is, and let's say that set pressure is going to be at 8 psi. I am going to come over to the max flow of the blower, and I can see the max flow is going to be 900 CFM, and now I need to find a relief valve that's going to be a good fit for it. So I'm going to go to relief valves on our page, and we're going to go to 2-inch weighted relief valve. And I can see my max relieving capacity is 985 CFM. So I now know that a 2-inch weighted relief valve can relieve everything that I need to relieve for a 409 ram. I said it was set at 8 psi, so I have a curve for the relief valve. You can see the set pressure and the volume. So I know at 8 psi I'm going to be relieving at right around 780 CFM. So I can actually go into a 409, go back to that 409 ram page, and I can find the pressure curve. And I'm looking at 8 psi, and let's say that my blower is spinning at 3000 RPM. I can see that I'm going to be relieving 600 ICFM, and that's the inlet CFM on the blower, and that's how we size relief valves. So just to confirm, hey, I'm at 8 pounds, I'm well above the 600 CFM, so this 2-inch relief valve is a good choice. Now let's say that we go up in size to a 412 ram, and again, if we don't have much information on the system, I'm just going to size the relief valve off the max flow. That's 1199 for CFM, so just under 1200 CFM. I'll go back to my curve for my 2-inch valve, and I can see I'm right under 1000, so that's not going to have enough capacity. Again, this is if we don't have enough information on the system. So now that I know that 412 ram is going to relieve, it's going to have more capacity in that relief valve, I am going to go back to our relief valve page. So again, under accessories, we'll go to relief valves, and I'll go to the next size up, which will be a 3-inch relief valve. and I can see that my relieving capacity is 2,216 CFM. And if I want to go see what it'll relieve at 8 psi, just go to our curve. And then my set pressure is down here again, 8. I'll go to 8, and then I'll come up, and it looks like we're right at 1,600 CFM. So in this case, a 3-inch weighted relief valve will be a good fit, and I can always go back and double check to see if I have enough capacity in my 2-inch valve because it was going to be cheaper. 412. I can go down to this curve. We're at 8 psi, we're at 3,000 RPM, we're at 800 ICFM. So 8 pounds, 800 ICFM, and I can see that I am just shy of the capacity that I need on a 2-inch weighted relief valve. So I'd have to bump up to a 3-inch weighted relief valve. That's just a quick overview on how you size relief valves. If you guys have questions, we can always help you here at PD Blowers. We're just going to ask, what your flow and pressure is. If you don't have that information, there's ways that we can figure it out, and we could also just size that valve off the max capacity of the blower. Quick recap on what we've already gone over. We have 2 different styles of relief valves. We have spring-loaded relief valves and weighted relief valves. Now, if it's on a system that's going to be moving, whether it's on a boat, trailer, or a truck, go with the spring-loaded relief valve. Now, if it is going to be a static system that's permanently installed and it's not going to be moving anywhere, I'd strongly recommend you go with a weighted relief valve. If you don't think you're going to be able to do any maintenance on it, or you don't have enough maintainers to maintain a weighted relief valve, a standard weighted relief valve, go with the 316 stainless steel option. It's a lot more expensive, but just peace of mind, if you don't do maintenance on it, the valve's not going to lock up. It's going to be fine. That being said, it's significantly more expensive, but again, you're not going to do any maintenance on it, go ahead, spend the money, peace of mind. If you guys have any questions, comments, or concerns, feel free to reach us at PD Blowers. We're here to solve your problems. All right, hopefully this video helps you guys determine which relief valve's a good fit for you. If you guys have any questions, comments, or concerns, feel free to reach out to us at pdblowers.com. I'll also put a link to our website in the description below.